Okay, so today we're going to learn the other trig functions. So there are, let me get this on here where I like it. We have learned sine and cosine, and so we've learned that sine, if you have a right triangle, is opposite over hypotenuse. And so we know that sine, let me write it up here, sine is opposite over hypotenuse. And we know that cosine, and I should say of an angle because it's always of an angle, is adjacent over hypotenuse. And that's true. But today we're going to learn 4 other trig functions. We have already learned tangent. Tangent in a right triangle is opposite over adjacent. That's true. But also, tangent can be thought of as the sine function over the cosine function. And that is wherever it's defined. So that is tangent is sine over cosine. This is a new identity we're learning. So that's a new way to think of tangent. If we kind of flesh that out, I guess, let me get a piece of paper that I can draw on. If we look at that, if we say, okay, tangent, can we make this make sense to us? Tangent, if we look at a right triangle, right, is we know it's opposite over adjacent, but they just said it's the sine over the cosine. And that's true. Let's see. The sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse. And so if we do division of fractions, keep, change division, change to multiplication, multiply by the reciprocal, keep, change, flip, hypotenuse over adjacent. These will divide out and we get opposite over adjacent, which is what tangent is. So tangent is opposite over adjacent, but it also can be sine over cosine. That is a new identity. Now, here are the reciprocal identities, which we are about to look at. One is for, here is, maybe this light is a little too bright right there. Okay. Here is, we know the sine function is abbreviated SIN, okay? And we know that the cosine function is abbreviated COS, okay? We know that the tangent function is abbreviated TAN. So we just learned this new thing about tangent is equal to sine over cosine. But here are the reciprocal functions, and reciprocal is when you take 1 divided by that function. So the reciprocal identities, the first one we're going to look at is for cosine. No, I'm sorry, cosecant. Cosecant is what this is called. And cosecant is abbreviated CSC, and it is defined to be 1 over the sine function. And then secant, this is the full word, secant, is abbreviated SEC, and it is 1 over the cosine function. And then cotangent of an angle is 1 over tangent. And this is cotangent. So who goes with who? Sine goes with cosecant. So how I put these together is the simplest one, sine, goes with kind of the most complicated one, cosecant. And then the other two go together. Cosine goes with secant, and tangent is easy to remember because it goes with cotangent. These are the reciprocal identities. So on your sheet there, we're going to see them all kind of laid out there. Reciprocal identities, cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. The reverse of these is true as well. Sine is equal to 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. And that is when these are defined, okay? There are times when you'll find yourself dividing by 0. That's when it's not defined. Okay, the quotient identities are where we take tangent and we look at it as sine over cosine. And so since cotangent is the reciprocal of tangent, cotangent can be thought of as cosine over sine. Okay, now there's a few more identities for us to learn. We'll come back up here and look at these two in a minute. First, I want us to look at these. The 6, number 1 says, find the exact values of the 6 trig functions. What are the 6 trig functions? Well, it's the sine of an angle and the cosine of an angle and the tangent of an angle. And what goes with sine is the cosecant of an angle. And what goes with cosine is the secant of an angle. And what goes with tangent is the cotangent of an angle. And so when I'm first learning this, and even now I write these down beside each other because these two are reciprocals, these two are reciprocals, these two are reciprocals. So those are the 6 trig functions. Now, I'm going to define these trig functions for any angle using a point. So let's do this. Find the exact values of the 6 trig functions if the terminal side of an angle x contains the point -5, 12. Okay, here is the terminal side, means where it stops. So this is the initial side, the positive x-axis. And -5 would be about here, left -5. -12 would be down here, -12. So let's just say that this is the point P. This is -5, -12. Okay. Now, so that means the terminal side of this angle, so this is the angle, right, is -5, -12. So what we're going to do is we are going to draw, oops, I'm going to do a better job drawing our reference triangle in there. We learned about reference triangles, so let's do this. Here is our reference triangle, and we're going to find the 6 trig functions for this little reference triangle here. I'm going to call this X. And so it will be true for every angle, for this whole big angle, as long as we adjust for the quadrant signs. What is this distance from here, the origin to here is 5, but we're in quadrant 3, so this is a -5. What is this distance from here to here? It's 12, but we're in quadrant 3, so this is a -12. We can use the Pythagorean theorem, a squared plus b squared equals c squared, to find out this length of this part of the triangle, and we would find out that is 13. The hypotenuse will always be positive, okay? The legs may be positive or negative depending on what quadrant we're in. Since we're in quadrant 3, we went left, negative, down, negative, but the hypotenuse is always positive. Now, to call out these trig functions, the sine of angle x is opposite over hypotenuse. So this will be -12 over 13. The cosine is adjacent over hypotenuse. So this will be -5 over 13. The tangent of angle x is opposite over adjacent. So that would be -12 over -5, or a +12 over 5, because a negative over a negative makes a positive. Now, I always do this because it's just way easier. I know that cosecant is reciprocal of sine. So the reciprocal of -12 over 13 is -13 over 12. And the reciprocal of -5 over 13 is -13 over 5. And the reciprocal of 12 over 5 is 5 over 12. And so this is how I get the 6 trig functions for this angle. Let us go again. Let's look at number 2. Number 2 says this. Find the exact values of the other 5 trig functions of the angle x, given that the sine is 4/5 and x is in quadrant 2. Okay, this time they gave us all the information that we need, but in like a little bit of a different way. They told us that the sine is positive, okay, and the sine is the y value, right? Okay, so the sine of the angle, this x just represents an angle. That doesn't mean the x value. The sine of this angle is positive. Where does that happen? Well, that happens in quadrant 1 and quadrant 2. And it tells us that the angle x is in quadrant 2. So we know we're in quadrant 2. So here we go. I don't know exactly where it lands, but I know that the terminal side, whoops, let me draw straight, try to draw a straight line. The terminal side of this lands in quadrant 2. Get in there. Okay, good. We'll just have to do this. Here's my initial side, and here's my terminal side. So what I'm going to do is draw my reference angle. Here's my reference angle x. Okay. All right. If we adjust the x and the y lengths of this triangle according to what the quadrant it is, then we can go off of the reference triangle. So it says that the sine of x is 4/5. Okay. But the sine of angle x is opposite 4 over hypotenuse 5. Now, I'm going to go through, find the, I'm going to call this A, this B, this C, and I'm going to say, okay, A squared. I didn't do it up here, but you could. We would say 5 squared plus 12 squared is C squared, and so we'd get 25 plus 144 is 169, and we take the square root and we'd get 13, and that would be positive. Okay, I'm going to do it in more detail here. A squared plus B squared, 4 squared is C squared. So I get that A squared plus 16 is 25. I get that A squared is 25 minus 16, which is, let me just do it here to make sure I'm not messing this up. 15, 1, it's 9, is 9. So A is 3. Okay, A is 3, but this is technically plus or minus 3, right? We make the right decision. We don't guess. We don't hope. We don't just try something. We look and say, we're in quadrant 2. So to get here, we would go left, which is a negative. So this is a -3. Now we know everything. This is a known right triangle, a 3, 4, 5 triangle. Okay, so here we go. Let's write the exact values of the other 5. So I'm going to write down that the sine of x is this, just because I want to, because this is my nice routine. If I write down sine, cosine, and tangent, these are the first main 3. Then define the other 3, cosecant, secant, cotangent. That's very simple, right? So the sine of x is 4/5. The cosecant is 5/4. All right. Now the cosine of x, all right, we've adjusted for the quadrant is adjacent over hypotenuse, so it's -3/5. -3/5. Secant is its reciprocal, -5/3. The tangent of angle x is opposite over adjacent, or -4/3. So the cotangent is its reciprocal, -3/4. All right, that's number 2. Now we're going to go back up here and have a look at these other identities for a second. Identities for negatives. And this will make even more sense to you once we learn the graphs of these. But basically, what these are saying is that sine function and the tangent function are odd functions. This is in algebra, if you take the negative of the input x, and it produces negative f of x, we say that this is an odd function. If you take the negative of the input and it produces the original output, we say this is an even function. This is what an odd function does. This is what an even function does. And we'll look at that again when we look at the graphs. But basically, what they're saying is that what these identities say is that the sine of negative x is equal to the negative sine of x. And the tangent of negative x is equal to negative tangent x. So these are odd functions. And the cosine, however, if you put in the negative of x, you get out the same thing you would as if you put in regular x. This is an even function. Okay, let's pop down here and look at number 3. We're going to use this. Oh, well, first I have to develop this for a second. Okay, this is not just saying sine, cosine, tangent. We need to develop this for secant, cosecant, and cotangent as well. So let's develop this. The secant of x is equal to 1 over the cosine of x because those are reciprocal functions. And what would the secant of negative x equal to? Well, that would equal to 1 over the cosine of negative x. But if we look up there at the identities for negative, we know that this is really equal to 1 over the cosine of x. So this is equal to the secant of x. So we've just developed another identity, which says, I'm going to add it right under here, which says that, let me do it in a nice bright color, that the secant of negative x is equal to the secant of x. Let's go for the sine of x. Let's look at what happens here. I'm just going to do it in this little space right here. Let's look at the cosecant of negative x. Well, that's equal to 1 over the sine of negative x. All right. But 1 over the sine of negative x is equal to negative 1 over negative the sine of x, according to this. And so that's equal to negative cosecant of x. So we've just developed another identity, which says that the cosecant of negative x is equal to the negative cosecant of x. So this is also an odd function. Let's look at what happens for, this is just where I can have a little space, the tangent of negative x. Only let's figure it out for the cotangent of negative x. What happens here? Well, the cotangent of negative x is, if I go to this quotient rule, cotangent is equal to the cosine of an angle divided by the sine of an angle. But we know that the cosine of negative x is really just regular cosine of x. And we know that the sine of negative x is negative sine of x. And so this is really negative cosine over sine, or negative cotangent of x. So what we have is another identity. We have that the cotangent of negative x is equal to negative cotangent of x. So we've developed 3 more identities, and we will see more about developing identities in, I think chapter, I forgot which book, what chapter, but when we get to verifying identities, that's what we'll get to. All right, now we needed to develop these 3 because of question 3. If the secant of t is 5.1, then the secant of negative t is, well, if we know that the secant of negative x is the secant of x, then we can say that this is also 5.1. Even though we don't know what angle t is, we know that that's true because this is an even function. The cosecant of t is 1.7. Then the cosecant of negative t, what will that be? Well, we have developed this identity here, which says that if you put in the opposite of the angle, then it ends up being the negative of the regular angle. So if they say the cosecant of t is 1.7, then the cosecant of negative t would be the opposite of 1.7. So that's how that works. The tangent of t is negative 2.4, then the tangent of negative t, since this is an odd function, would be positive 2.4, because it's going to be the negative of negative 2.4. And the cotangent of t is 3.8, then the cotangent of negative t would be the opposite of that, negative 3.8. All right. And on the next video, we'll have a look at these last three identities, which are very important, the Pythagorean identities. But that's enough for this one.